Okay, guys, pre-lesson 3-1, day 2, fundamental identities. But this is solving equations that have fundamental identities. So if you're thinking, oh my goodness, this is going to be directly connected to what we did yesterday or the day before, not really. It's going to boil down to your ability to understand factoring. This goes back to Algebra 2, but you got to understand that it's disguised with these trigonometric expressions or terms, okay? So, to help you bridge the gap from the world of the unknown, the world of the known to the world of the unknown, I'm going to take you back and do a few examples that you should remember how to do. So if you remember this is a trinomial. Now notice it's set equal to 0, set equal to 0, set equal to 0, set equal to 0. So if this was actually like this, before you do a darn thing, make sure you set these equal to 0. So we'd have to add 1, and then we would get what we had back. It would be plus 1 equals 0. Now this is a very simple trinomial. Remember the trinomials? You have to factor them. So we'd say, hey, if that's a 1, then I would go like this. That's x squared, so that's x, that's x. I'd have to look at this and think, what two factors of this add up to 2? Well, that'd be 1 times 1. So I would put a 1 here and a 1 here, and that'd be plus 1 and plus 1. And my two solutions, what plus 1 is 0? Negative 1. What plus 1 is 0? Or negative 1. So in this case, it'd be negative 1 double root. If you want, this is a review of Algebra 2. Why did I do that? Because now you're going to have these to solve for today. Guess what? This thing is almost exactly like this thing. This is like your x squared. This is like your 2x. And this is like your 1. Same exact problem, kind of, sort of. But so if you think of this as x squared, then you're just going to say, oh, I'm just going to put 1 sine of x here and sine of x here. Now, a lot of students want to say, well, x times x would be x squared. No, it's sine squared. And then that x, remember that x represents a degree measure, like 30 or 60 or 45. That's not going to change. And then what are two factors of 1 that add up to 2? Well, once again, it's 1 and 1. Now here is a huge difference compared to these and these. If I look at this, I'd have to go, okay, I'm going to literally set this equal to 0, and I'm going to literally set this equal to 0. Now notice they're the same thing. So I'm going to subtract 1. So I get sine of x equals negative 1. And over here, I'm just going to get the same thing. So really, I don't need to solve both of them. I just need to solve one of them. So the question is, where in the world could sine actually equal negative 1? Well, you have to remember that it's opposite over hypotenuse. So that means the opposite side would have to be the same as the hypotenuse, but the opposite side has to be negative. So let's investigate. 0 degrees. Nope, because my opposite side is 0. 90 degrees. Well, we're getting closer because my opposite side equals my hypotenuse, but it's not negative. How about 180? Nope, because my opposite side equals 0. Aha! Getting warmer. Here we go. Here's my opposite side. It has to be negative because this is down. My adjacent side is disappearing, but my hypotenuse, there it is. My opposite side and my hypotenuse are equal, but my opposite needs to be thought of as negative. So that would be 270, or 3 pi over 2. You see, factoring is just phase 1. Solving is where your trig comes into play. Okay? Now, let's tackle these two. A little bit different. How do I factor this? Here's the deal. I'm going to demonstrate something that you should never, ever do. A lot of students are going to look at this and say, I'm going to divide by x. Don't you ever do that. Now watch what happens if I do that. I would get 2x minus 1 is 0, add 1, and I'd get 2x is 1, and I divide by 2, I get x is 1/2. And I think I've done it right. But problem is, you eliminated an answer. So rule number one, even if it doesn't make sense to you, what are we trying to find? We're trying to find x. Never ever divide by the variable you're trying to find. So keep this in mind. We found that x is 1/2. How are you supposed to do this? Take an x out. And now we have it. Now we have two situations. X, what can I put in here that would cause this all to be 0? X can be 0. What do I do with that? Well, if you're confused, set equal to 0, solve, and then 2x equals 1, divide by 2, I get 1/2. See, I get two answers. I want you to notice something. My highest power of x is 2. That means I'm going to have two answers. So when I got one answer, how come? Because I divided by the variable I was trying. That's not wrong. It's just only half of the answers. So never, ever, ever divide by the variable that you're trying to solve for. It's just a big old no-no. Now, let's take it to here. Now remember, you see this 2 sine squared x? The 2 is the 2. The x squared is the sine squared. The x is just the sine, okay? So you kind of have to ignore these. I know it's hard to do, but we're going to factor out a sine of x. And that would leave us 2 sine of x plus 1 equals 0. Now, if you're uncomfortable with this, just distribute it back through and ask yourself, would I get the original back? And the answer is yes. If I distribute that to that, I get this. If I distribute that to that, I get this. Well, now we have two trig problems to solve. Number one is right here. I need to set sine of x equal to 0. And then number 2 is right here. 2 sine of x plus 1 has to equal 0. Well, if I look at this, how in the world could sine equal 0? Well, remember, it's opposite over hypotenuse. That would mean my opposite side would have to be 0. Well, that happens in two places. It happens at 180. If you look at this drawing, see my opposite side? But it also happens at 0. So this one problem gives me two answers. X, see that's what this is 0 degrees or it's 180. Now let's move over to here. Subtract 1, subtract 1. 2 sine of x equals -1. Divide by 2, divide by 2. Sine of x equals -1/2. And if you remember, how could sine be -1/2? Well, by definition, it's opposite over hypotenuse, okay? So that means sine could equal -1/2 if I had a drawing like this. -1, square root of 3, 60, 30, 90, and 2. And see, how would I answer this? Would I say it's 30? No, because it wants to know how far you flip your spinner to get to this situation. So that'd be 180 plus 30 would be 210. That's one way I could get sine to be -1/2. Another way would be to go over here. There's my -1. There's my 60. There's my 2. There's my square root of 3. See, sine of this would be -1/2, opposite over hypotenuse. But I don't say 30. I ask myself, how far do I have to swing my spinner to get there? And that'd be 330. So this one math problem right here produced 1, 2, 3, 4 answers. New stuff.